Yo, what's up guys? In this video, it's not going to be anything too crazy. You're just going to learn the basics of how a fly system should work. Without further ado, let's get straight to it. First step is going to be to create a local script inside of starter character scripts. The core of the system is going to be user input service. This service is to detect keys that are pressed. Then we want to reference the player. So then we will be able to reference the local player. And finally, we want to reference the run service. So each frame, the movement of the character will be updated. Now I'll create two functions. How the fly system is going to work is that when we press the key that we want to activate the fly with, so in our case we want the fly to be activated with the letter F. When we press F on our keyboard, it's going to activate the fly system. So basically, with all of this information that we have right now, I want you to think of it like this. When the player presses F, this function will give to the player a certain amount of linear velocity and will create an align orientation too. The linear velocity will be for the movement and the align orientation will be for the rotation of the player. We want this function to basically create this for the player, and then when the player presses F again to disable the fly, we want this function to run because it's going to remove the linear velocity and the align orientation and any other attachments or effects that we will add using this function. This function will be to add the stuff that will constitute the fly system, and this function will remove all the components of the fly system. To go ahead and attack those functions and add logic inside of them, we first need to make a function about input began. So we're going to do uis.inputBegan connect function input GPE if GPE then return end. So if game processed event then return end. So let's say I'm in the chat and I use F to write my sentence, then it's not going to activate the fly system, so it's going to end the function. Now we want to tell the script that if the player presses F, so if input.keycode equals key, then we want the fly to activate. And how we're going to convey this information to the script, we're basically going to make a fly value. Flying is going to be false, okay? And when it's false, there's no flying. When it's true, the player is flying, okay? So if the player presses F, then if flying equals true, then play the fly function, and else then remove fly. A more clean way to write this condition would be if not flying, then fly, else remove fly. So if flying is not false, which means it's true, then play this function, else. So if flying is not true, then that means it's false. Then you're going to remove the fly. Now, to make those functions have impact on the character of the player, because this is what's going to be impacted, it's the character. And that's also pretty much why we put this local script inside of starter character scripts, if you didn't understand that. We need to reference the humanoid root port. So local player, player.local player, local character equal player.character, or player.character added weight, and local HRP equals character wait for child humanoid root port. So just put HRP here, HRP here. HRP. Reason I'm doing this is because the attachment, the linear velocity, and the align orientation will all be inside of HRP. Okay, but parent equals HRP. You're probably going to ask, hey, you didn't put local in front of those variables, so it's not going to work. Of course, because I do not want those variables to only be inside of this function. My logic is that I want those variables, so attachment, linear velocity, align orientation, to be accessible all throughout the script, okay? So I want this same variable to be also accessible inside of this function. So when will come the time to delete it, it's going to delete this variable, okay? So I will not have to create another variable to reference this variable. And to do that, it's pretty simple. You just got to call them and give them nil value. So local attachment, local linear velocity, and local align orientation. So now that you did this, you're going to be able to call them all throughout the rest of the script. Now it's giving an error because the script, it doesn't even know what it is, right? Like now it's nil, okay? So it doesn't have any value and I'm assigning a parent to it, so it doesn't make sense to the script, right? So this is why we're going to give it another value. So we're going to make it become something. So attachment, cool, instance.new attachment. Now the error went away because now the script knows that attachment is not nil, but it's an attachment, right? And once again, why I put the local here, it's really to be able to access this attachment value even in the remove fly. So let's say I put local attachment here, then when comes the time to delete the attachment, then you see whatever I'll put after, so destroy or whatever, it gives an error because like the script doesn't know what it is, right? Because the attachment is inside of fly and after the end it's not accessible anymore. So if anything that is called attachment is called outside of this function, the script will not know what it is. And this is pretty much why we put this local value to attachment, because we want it to be accessible throughout the whole script. So I'm pretty much going to do the same thing with the linear velocity and the line orientation. Why I'm doing this with this function is because when the player presses F, it's going to give it a linear velocity which will allow the player to move in the air, and the align orientation will allow the character to rotate. Now I'll just add the properties of the linear velocity and the align orientation along with the attachment. This line is basically saying that we want the linear velocity to be attached to the attachment, and the attachment will be a child of the humanoid root port. So with mat.huge, I'm basically saying to the script that there's no limit of strength that the linear velocity can apply. This line is basically saying that we want the linear velocity to act with the axis of the world. Then you do the same with the align orientation. This line is basically saying to the script that the align orientation can use any amount of strength required to rotate. The responsiveness is basically how fast the align orientation acts. In this line, I set the mode of the align orientation to be one attachment. So what it does is that instead of trying to match two attachments together to influence the rotation of the character, so instead of trying to match attachment 0 to attachment 1 to rotate the character, it's only going to use one attachment. So it's going to use attachment 0 as the reference. Now that we were done, so this function will basically create an attachment, linear velocity, and align orientation inside of the character. Then for the remove fly, it's basically the same logic, but just to delete those. It's pretty simple. Just write attachment.destroy, and here you just put linear velocity destroy and align orientation destroy. Now what I'm gonna do is that I'll handle the update of the movement. So think of it like this, okay? Each frame that you hold W, A, S, or D for the arrow keys after pressing F to move around while you're flying, the game needs to update each frame and needs to constantly add a linear velocity and an align orientation when you rotate while flying to your character so it looks smooth and it doesn't look like bad, right? You needed to update each frame. How to do that? Just follow along, you'll understand, and if you don't worry, I'll still explain what I'm doing. So now you're gonna write a table. It's gonna be called local keys equal W equal false, A equal false, S equal false, D equal false, space equal false, left control equal false. So basically that's the keys you want the fly system to be controlled by. If you also want the arrows to control the fly system, because right now it's just gonna be like WASD space and left control, space to go up, left control to go down, and WASD to move around. If you want the arrows to control too, you just add them to the table. So it's gonna be like left arrow or something like that, I don't know. But anyways, it shouldn't be too complicated for you to do. For worst case, I'll just add it in part 2 because really want me to show you how. Now, as you understood, we're gonna handle the movement. So we're gonna go into input began, okay, right after the if statement. We're gonna write if input.keycode is equal to enum.keycode W. Then I want it to, when the player presses W, the value of W becomes true. And how we're going to set this logic up is that I'm going to create another function. We're going to call it setKey. So local function setKey, key value, and keys key equals value. Okay, so the key will be the key that you press. Okay, so WASD space left control, left arrow, up arrow, whatever. And so inside of the keys table, the key that you decide to change the value of, it's gonna change its value. In simple words, when I press W, then set key W true. So when I press W, I'm gonna go into the table. I'm gonna find W. W is gonna be the key, and I want its value to not be false but be true. So when I hold this value, it is true. And when I stop holding this value, and this is where the input ended will come in handy, then we're gonna set it back to false. And it's pretty simple. And so it's the same logic with the rest of the keys. So for A, for S, for D, for space, for left control, you know, like the script understood what I'm trying to do. And so you just copy this, or wait, hold on. And so you just do the same, but instead of true, you write false for input ended. So every time you press W, for example, the key is going to go here inside of this function. It's going to search inside of the keys table. It's going to find the value that you're referencing. This is pretty much why we wrote it like this. And then it's going to give it the value that you gave it. Okay, so instead of false, it's going to give the value that you gave it, which is true or false, and it sets it. Reason I'm explaining and re-explaining, it probably seems like I'm over-explaining the thing. It's because when I first tried to do this script, it was very confusing for me. It took me a long time to figure it out. So I just want you guys to understand as quick as possible so we can move on and do more things. Now we're at the step that when any of those values are true, we want the character to have forces be acted upon. So we want it to have the linear velocity and align orientation have an effect on it and actually move around in the direction that the camera is facing. So now we're going to reference a run service, a render step, connect function. First of all, if there's no linear velocity, return and. If there's no aligned orientation, then return and. If there's no attachment, then return and. This will stop the script from running if any of those is not present, okay? Because those are the main factors that will make the fly work. Think of it like this. When you add force into a direction, you want it to be the direction the player's camera is facing. And this is why we're going to reference the camera of the player. And if there's no camera, then return and. Since we want the character to move around towards the direction of the camera when the inputs are pressed, because of that, we're going to reference local look vector equal camera dot cframe dot look vector, local right vector equal camera dot cframe right vector. So here we're going to do local look direction equals vector dot 3 new look vector dot x 0. The reason we put 0 here is because we want the space and the left control to control the y-axis and not the x and the z-axis, okay? The x and the z-axis is going to be for the WASD or the arrow keys depending on how you want to do it. So lot vector dot z, now local right direction, and now we're going to do local move to is going to be equal vector 3 dot 0. This is the equivalent of vector 3 dot new 0 on all axes. Okay, so that's the same thing. Reason I'm setting this variable up like that is because we want to have a sort of base. So we want the script to know like, okay, it starts here at 0 and then it's gonna add values to the direction the player is facing while he presses the keys. Okay, if keys dot w, then so if the player presses W, then move to look direction. If keys is S, so we're gonna move backwards. If the key is D, we're gonna move in the right direction. If the key is A, we're gonna move in the left direction. And now for the up and down, it's going to be local y-axis equals 0. If keys, so when we press space, then the y-axis will be equal to, I don't know, like 50. Else, if the key is left control, then y-axis is equal to minus 50. So it's going to go downward. And now we're going to set local final velocity is equal to vector.new, move through x, y-axis, and move to z. All of this, okay, we did it for one purpose. It was to update each frame. Update what? The linear velocity. We wanted to update the vector velocity, and we want it to be the final velocity. Okay, so all of this did this in order to properly update the property of linear velocity, which is vector velocity. And yeah, so normally everything should work. Okay, so when I press F, I press space, I go around. If I press control, I go down, I go up, I go up. Now what you notice is that I actually can move around, but I'm moving very, very slowly, okay? I'll fix this by adding this line. So if move to dot magnitude is bigger than 0, then move to is equal move to dot unit times 80. And here we can even like make it like cleaner. We can make this a variable. So local apply speed equals 80, so then it's easier to update after, like when the script is bigger. Apply speed, because you know, like look direction, it's looking towards the camera, but the camera is looking towards like small values. Okay, it's the values are super small, and we're multiplying those units, so the XYZ units by 80, so by the fly speed, so then the values are going to be bigger, and so the vector velocity can also be bigger. You're going to see a drastic difference with that. So when I press F, I go up, okay, I move much more faster, okay, move around, it's nice. Okay, so when I press F, okay, it doesn't seem to stop the fly. Okay, that's because, yeah, I just did a mistake here. So you just go here. So flying equals not flying. And so if flying, then fly FRP. That's what I should have done at the beginning. If input.key code is equal to key, which is F, then flying will not be equal to false. And if flying is true, then play the fly function. And then when I press again, it's F, flying equals not flying. So since we pressed F the first time, flying is true. So flying becomes not flying. So it becomes false. If flying is false, then else. So if it's not true and it's false, then play the remove function. So it's going to remove the attachment, the linear velocity, aligned orientation. If we play again and I press F, you see I fly, and I press F again, then I go back down. I'll just go inside of my character and show you inside of my humanoid root point how when I press F it creates an attachment, an aligned orientation, and the linear velocity all at the same time, and when I press F it all disappears. That's exactly what I wanted. That was it for this video. It was a pretty simple script, okay? As you can see, the system is like not the best, because my main purpose with this video was just to make you understand the basics of a fly system. I will make a part 2 where I will add some features such as a boost, effects, and stuff like that. And I'll probably like even make a part 3. So yeah, that was it for me in this video. I hope it was helpful. See you in the part 2.